right, so exercise number 2, the electroscope. So we just did a really basic exercise and playing around with the pieces of paper, and you're going to have to explain why that worked. So why is it that the little pieces of paper that were uncharged were able to be picked up by a charged object? Because most people think that things have to be charged to be able to attract each other. Now technically that's true, and the thing is, the question is, how do those little pieces of paper that are neutral get the opposite charge? Just how does that happen? Okay, so I dropped this right before I'm doing this exercise, but I think it'll still work. I had to put the glass back in its case. An electroscope is kind of a simple device. All it does is shows you that a charge is present. It can't really tell what charge it is. And there's a little needle that will move, and it's attached to a metal post. So the metal post goes all the way up to where this ball is. So I'm going to put charged objects near the ball. Now right now you can see nothing's happening because my glass ball isn't charged. I can touch it, I can touch this. And the case is insulated from this metal post through this plastic bushing right here. And then you can see that there's a needle that's freely moves around as I chuck it a little bit. So what I'm going to do is take my PVC pipe, rub it with some wool, and then I'm going to put it near the top to see what happens. Let's just show you how this thing works. I'm going to put it near but not touching. Now the closer I get, the further away that little thing moves, and then it goes further away. And take it away. So remember, the PVC rubbed with wool becomes negatively charged, so it looks like that little needle is swinging out with a negative charge. Okay, so let's do the same thing with my glass rod. I'm going to rub it with silk. Sometimes it doesn't work with silk. I try animal fur as well, but it should be a dry day. Glass actually sometimes is a little problematic because it's a little harder. It doesn't get as strong of a charge. All right, so now let's put it up here and see what happens. Yep. The glass rod. It's not to do anything. Okay, I'm going to rub it with animal fur. See if this is better. I happen to pick a smaller glass rod. I should have picked a really thicker one. The thicker ones get bigger charges, but I just grabbed the thin one from the rack, so. Okay, now you can see a little reaction. See that? I guess the animal fur is what I have to use. Again, it's not as big as the rubber rod. It's just the nature of the beast. I happen to be using glass and animal fur. It turns out that the PVC pipe has an extraordinary affinity for electrons, so it makes a really, really good charge indicator. So no matter if you put a positive charge near the ball at the top, notice I'm not touching it, I'm just putting it near it and then moving it away. Then I'm putting it near it and putting it away. Or a negative charge, it acts the same way in both cases. So an electroscope, a scope usually measures something. This, what it does is indicates whether you have a charge on an object. Now what we're going to do is charge the electroscope now by induction. What I'm going to do is take this rubber rod, which I know has a charge. Now I'm not going to touch it, but what I'm going to do, let's see if I can just kind of hold the iPad at the same time I'm doing it. I'm going to put it near the electroscope. On the other side, I'm going to touch it with my finger. See my finger here? While it's nearby. And then I'm going to take the negative rod away. So notice nothing is near the rubber ball, but the needle is still pointing. Is still pointing away. It's displaced. What I did is actually charge the electroscope. Normally you cannot. One more thing I forgot to do is the metal rod. So let me. Well, that's okay. We can do the metal rod later. So what I'm going to do now is take the rubber rod and move it back towards the ball. So you see it charge electroscope. I am now moving the rubber rod nearby, and it looks like it's moving towards it. If I put the positive near there, it moves away. Now, let's let it settle a little bit. See how it moves it away when I put the positive, the glass rod nearby? Let's let it settle again so you can definitely see. I haven't recharged it, so it's probably lost a little bit of its charge, but see it? See, it moves away when the positive charge, and it moves towards it when you have a negative charge, near the ball but not touching it. You're going to have to figure out why that is. First of all, you have to figure out what charge this thing is. Now, in the theory section, or like in the introduction, you should have gotten why this thing works or how you charge it. When I put the rubber rod nearby but not touching it, where do the electrons go in the metal? This is negatively charged, so do the electrons come towards the rubber ball or down near the bottom? So once you answer that question, then you have to ask yourself, what happens when this is nearby and I put my finger, I touch my finger to the ball? What is my finger doing? Is it putting electrons on or taking electrons away? So again, when you're putting the rod on one side of the ball, the electrons are either going to go to the side of the ball or they're going to go to the opposite side, the right side, and down below. So the electrons either will come up from the bottom and pile up on this side, meaning that there's less electrons on this side, or the electrons are going to go away from the rubber rod, which is negative, and they're going to pile up on this side and below. So you have to ask yourself those questions then. If I put my finger on here, is my finger going to take away electrons or give electrons to it? So it all has to do with the finger. If the finger gives electrons to the system, then it becomes a negative charge. If the finger takes electrons away, then you have a positive charge. So go through that and figure out what charge the electroscope has right now. Then, once you figure out the charges, now explain the behavior when I move this negative rod to it. Why does that needle go less neutral? In other words, it looks like it's becoming, not less neutral, more neutral. When it's neutral, the needle isn't displaced at all. So when I put the negative rod near the ball, the needle becomes more neutral, less charged. So why is that? So obviously at the bottom, these two things have to be the same charge, so the needle is being pushed away because these things have the same charge. Now when I put the positive side, the positive up there, it moves away. That means that these two become the same charge even more. It becomes more charged or less neutral. So you explain all those things in your handout. And the last thing we're going to do is figure out what the metal has. What I've just done is discharged it. I just put my hand on there. And I usually put the back side of my hand because I know I haven't been like rubbing anything with that. So what I'm going to do is rub the metal, this metal rod. I'm going to rub it with different types of fur. Well, first let's try it with wool. I'm going to rub it with wool, and let's see what happens when I put the metal rod near the ball. Let's see if you can see if it does anything, even a little. All right, so the metal rod doesn't look like it's doing anything. Let's rub it with rabbit fuller silk. So, maybe it's like the glass. Maybe it gets a positive charge. Let's go see. Do you see any? I don't see any sort of motion whatsoever when I put the metal rod, and this is aluminum. It doesn't really matter what metal it is. Okay, so what you're going to have to do now is figure out why the metal rod has no effect. Why is it when you rub a metal rod with something, it doesn't get charged? So let's look at the PVC pipe. When I rub this with wool, the wool is giving electrons to the pipe. The pipe likes electrons, it attracts them. So it pulls electrons off the wool, leaving the rod negatively charged and the wool positively charged. So the electron transfer taking place. And the other end of the rod stays neutral because, it's an insulator, right? So think about what happens with the metal. and describe it, what the difference between a metal and this rubber rod or this glass rod is. Why do glass rods and rubber rods get charged? You can charge them by contact, but you can't charge metal by contact. And explain it thoroughly. I'm looking for, and I'll be able to tell if you actually understand this or not. So make sure you step by step tell me what's going on in an electroscope. Remember, this is the hardest part, to try and figure out what's going on.